Detroit, 1993. General Motors executives watched the first production Cadillac, equipped with their revolutionary new engine, roll off the assembly line. The Northstar V8 represented everything GM believed would restore American luxury supremacy. 4.6 liters of dual overhead cam sophistication, 300 horsepower of aluminum engineering excellence. The most technologically advanced V8 ever produced by an American manufacturer. It was supposed to save Cadillac. Instead, it nearly destroyed it. Originally developed by Oldsmobile, the high-performance 4.6-liter 90-degree V8 was General Motors' most complex engine, featuring aluminum block and heads, double overhead cams, and 4 valves per cylinder. Capable of producing 300 horsepower out of its 4.6 liters, 278.6 cubic inch, 4,565 cc displacement, the Northstar featured a cast aluminum 90-degree V8 block with 4-inch bore spacing, split into unitary upper and lower halves. The automotive press praised it as world-class engineering. Motor Trend celebrated its sophistication. Car and Driver marveled at its refinement. Yet within 5 years, that same engine would become one of the most infamous power plants in automotive history. Picture gleaming Sevilles and Eldorados in dealer showrooms, customers drawn by promises of European refinement with American reliability. Now picture those same vehicles abandoned on roadside shoulders, white smoke billowing from their exhausts, owners clutching repair estimates that exceeded their car payments. What went wrong? How did General Motors spend over $1 billion developing what they called their technological moonshot, only to create an automotive nightmare that would haunt Cadillac's reputation for decades? This is not just the story of an engine. This is the story of American ambition colliding with engineering reality, of brilliant innovation undermined by fundamental flaws, of marketing promises that became customer nightmares. The Northstar promised to prove Detroit could out-engineer Germany and Japan. Instead, it became a cautionary tale whispered in service bays across America, a name that transformed from symbol of technological superiority into synonym for expensive failure. This is the shocking truth behind the most hated engine ever to wear a Cadillac badge. The year was 1973. Cadillac experienced record sales as Americans still craved the massive luxury barges that defined success in post-war America. Chrome stretched for miles. Leather seats could seat football teams. V8 engines displaced over 7 liters and consumed gasoline like industrial machinery. Cadillac stood as the undisputed standard of the world, selling over 300,000 vehicles and commanding respect from Beverly Hills to Wall Street. Then the world changed. The OPEC crisis in 1973 saw large cars quickly fall out of favor, with many small, efficient cars were suddenly in demand from most customers. Gas lines stretched for blocks. Fuel prices skyrocketed. The American automotive landscape would never recover. Cadillac's response was catastrophic: downsizing without the engineering expertise to execute it properly. In 1977, Cadillac's D-body models shrank dramatically, but the brand's reputation for quality began crumbling alongside the smaller dimensions. The luxury that once meant solid construction and meticulous attention to detail devolved into cheap plastics and cost-cutting measures. The disasters multiplied throughout the late 1970s and early 1980s. The infamous V8 6.4 engine promised fuel economy through cylinder deactivation, but delivered only headaches and warranty claims. Customers watched their expensive Cadillacs stumble and stall as the primitive computer systems failed to manage the complex cylinder switching. The technology that was supposed to save fuel became a reliability nightmare that destroyed trust. Meanwhile, something unprecedented was happening on American shores. German luxury manufacturers were no longer exotic curiosities for wealthy enthusiasts. They were becoming mainstream alternatives for affluent buyers who valued engineering precision over traditional American luxury. BMW and Mercedes-Benz weren't selling comfort and status. They were selling sophistication and build quality that American manufacturers had forgotten how to deliver. BMW's Ultimate Driving Machine campaigns positioned their cars as precision instruments for discerning drivers. Where Cadillac offered floating rides and push-button convenience, BMW delivered tight handling and driver engagement. Mercedes-Benz emphasized their engineering heritage and meticulous construction quality. Their vehicles felt solid and substantial in ways that downsized American cars could no longer match. The knockout punch came in 1989. As the first model developed by Lexus, the LS400 debuted in January 1989 and redefined what luxury could mean. The LS400 was still almost $10,000 cheaper than the less powerful BMW 735i and more than $20,000 less than a Mercedes 420s EL. The V8-powered Cadillac Seville was slightly cheaper, but it had 70 fewer horsepower, and its quality was not at the same level. The impact was immediate and devastating. BMW's and Mercedes-Benz's U.S. sales figures dropped 29% and 19% respectively, with BMW executives accusing Lexus of dumping in that market. But Cadillac suffered even more severe damage. The LS400 proved that a manufacturer could build a luxury sedan that was quieter than a Mercedes, more reliable than any American car, and priced thousands below comparable domestic models. Until the launch of the LS400, the luxury sedan market was dominated by the Mercedes E-Class and S-Class, BMW 5 and 7 Series, Audi 106, and the Jaguar XJ. In the US, the Cadillac brand was the king. That dominance evaporated almost overnight as affluent buyers discovered they could purchase superior vehicles for less money. Cadillac's market position became untenable. The brand that had once defined American success was increasingly associated with retirement communities rather than corporate boardrooms. Young professionals with money to spend on luxury cars looked past American offerings entirely. The conquest sales that had built Cadillac's business model disappeared as import brands captured the most profitable customers. Internal market research painted an increasingly desperate picture. Focus groups revealed that Cadillac was perceived as outdated technology wrapped in traditional American styling. The engineering sophistication that defined modern luxury had passed American manufacturers by while they focused on cost-cutting and marketing gimmicks. General Motors executives realized they faced an existential threat. They could continue down the path of incremental improvements and cost reductions, slowly bleeding market share until the brand withered away. Or they could make a massive technological bet that might restore Cadillac's reputation as the world's premier luxury manufacturer. The decision was unanimous among GM leadership. Cadillac needed a revolutionary engine that would prove American engineering could not only match but exceed the sophistication of German and Japanese competitors. The investment would be enormous, the timeline would be aggressive, the technical challenges would be unprecedented for GM. Thus was born what would become known as the Northstar program. GM's most ambitious engine development project would either save Cadillac or destroy what remained of the brand's credibility. There would be no middle ground. What none of them realized was that their moonshot to restore American automotive supremacy would become one of the most expensive engineering disasters in automotive history. The late 1980s brought unprecedented crisis to General Motors' luxury division. During the 1980s, Cadillac's management wanted to re-establish the brand as a leader in sophistication, innovation, refinement, and prestige. The numbers told a brutal story of American luxury in retreat. Import brands were capturing the most profitable customers, while Cadillac struggled to maintain relevance with aging technology and diminishing prestige. The competitive landscape had shifted seismically. European manufacturers no longer represented niche alternatives for wealthy enthusiasts. BMW and Mercedes-Benz had become mainstream choices for affluent Americans who valued engineering sophistication over traditional luxury appointments. Their dual overhead cam engines represented the cutting edge of automotive technology, making Cadillac's pushrod V8 seconds appear primitive by comparison. Stiff competition from luxury cars of domestic, European, and Japanese origin put big pressure on Cadillac. The era of the dual overhead cam engine was on the horizon, and it looked as though Cadillac was about to be left in the dust with its high-technology 4.5-liter. The Japanese threat was even more severe. Lexus had demonstrated that Asian manufacturers could build luxury vehicles that exceeded European standards while undercutting American prices. The message was clear. Cadillac needed revolutionary technology to compete, not evolutionary improvements to existing designs. General Motors executives faced a stark choice. They could continue refining their conventional pushrod engines, accepting gradual market share loss as import brands captured younger, more affluent buyers. Or they could make an enormous technological bet that might restore Cadillac's reputation as the world's most advanced luxury manufacturer. Regarded as GM's most technically complex engine, the original double overhead cam, 4-valve per cylinder, aluminum block aluminum head, V8 design was developed by Oldsmobile R&D, but is most associated with Cadillac's Northstar series. The decision to proceed with this ambitious engine program represented the largest single investment in powertrain technology in GM's corporate history. The Northstar program would not be an incremental improvement project. GM committed to developing a completely new engine architecture that would incorporate every advanced technology available to automotive engineers. When the Northstar happened, it was a part of GM's rebuilding of the Cadillac brand. Money to finance it was shuffled from Oldsmobile, which resulted in Olds having to only facelift its products, which began its slide down the mountain. The corporate politics behind the Northstar development revealed how desperately GM needed this engine to succeed. Oldsmobile's future was effectively sacrificed to fund Cadillac's technological moonshot. The engineering team assembled for the Northstar project represented GM's most talented powertrain specialists. They would be tasked with creating an engine that could legitimately claim technological superiority over anything produced in Germany or Japan. The specifications they established were audacious by American standards: dual overhead cams, 4 valves per cylinder, all aluminum construction, and sophisticated engine management systems. The complexity would be staggering compared to traditional American V8s, where conventional engines featured simple pushrod valve trains and cast iron construction. The Northstar would incorporate precision manufacturing techniques previously reserved for racing engines. Every component would be engineered to tolerances that GM had never attempted in production vehicles. The timeline was equally ambitious. With import competitors launching new engines regularly, GM couldn't afford the extended development periods that complex projects typically required. The Northstar would need to be ready for production by 1993, giving engineers less than 5 years to complete what normally required 7 to 8 years of development and validation. The investment commitment was unprecedented. GM would construct new manufacturing facilities specifically designed for aluminum engine production. Supplier relationships would be established with companies capable of producing components to aerospace-level precision. Quality control systems would be implemented that exceeded anything previously used in American automotive manufacturing. The marketing strategy for the Northstar was as ambitious as its engineering. GM planned to position the engine not just as a new power plant, but as proof that American engineering could exceed global standards. The Northstar would demonstrate that Detroit could out-engineer Germany and Japan when properly motivated and funded. Cadillac's DOHC 4-valve per cylinder Northstar debuted in 1992, which at the time was its most technologically advanced engine. The development program moved forward with remarkable speed as engineers worked to meet the aggressive production timeline. The confidence within GM was infectious. After years of playing catch-up with import competitors, American engineers were finally creating something that could claim technological leadership. Internal communications from the period reveal engineers and executives convinced they were developing an engine that would restore American automotive supremacy. The Northstar would power Cadillac's most prestigious models, demonstrating the engine's capabilities in the vehicles where luxury customers made their most critical purchasing decisions. The Allanté would showcase the engine's sophistication in direct competition with Mercedes SL convertibles. The Seville STS would prove that American sedans could match BMW performance while maintaining traditional comfort. Corporate executives allowed themselves to believe they had solved Cadillac's competitive problems through advanced technology. The Northstar represented everything right about American automotive ambition: the willingness to invest heavily in cutting-edge engineering, the determination to compete on technical merit rather than price, and the confidence that American manufacturers could excel when properly challenged. The program moved forward with unprecedented speed and resources. GM was betting the future of Cadillac on a single-engine program, wagering that technological superiority would restore the brand's reputation and attract the affluent buyers who had abandoned American luxury for import alternatives. What they didn't realize was that buried within their revolutionary design lay fundamental flaws that would transform their triumph into automotive history's most expensive disaster. The Northstar program represented both the best and worst of American automotive engineering: brilliant innovation undermined by inadequate validation and overconfident execution. As development proceeded and production approached, GM executives celebrated their technological achievement. They had created the most sophisticated engine ever produced by an American manufacturer, incorporating advanced features that exceeded anything available from European or Japanese competitors. They had no idea they were about to unleash an automotive nightmare that would nearly destroy the brand they were trying to save. The specifications read like automotive science fiction compared to anything Detroit had previously produced. Introduced in 1993 in the Cadillac Allanté, Eldorado, and Seville STS, the 4.6 liters, 32-valve, dual overhead cam, all-aluminum V8 engine was a quantum leap forward for U.S. automakers. Where previous Cadillac engines relied on simple pushrod valve trains and cast-iron construction, the Northstar represented a complete philosophical shift toward European engineering sophistication. The aluminum construction of the Northstar alone represented a manufacturing revolution for General Motors, requiring entirely new production techniques and quality control procedures. Initially rated at 295 horsepower, the Northstar V8 has been ranked as one of the 10 best engines in North America by Ward's Auto World. It also beat out both Mercedes-Benz and BMW in horsepower per liter of displacement, fuel economy, and required maintenance. This was the validation that GM executives had desperately sought, objective proof that American engineering could exceed European standards. The competitive comparison was stunning and unprecedented for an American engine. While BMW's most advanced V8 seconds struggled to extract 280 horsepower from 4.4 liters of displacement, the Northstar achieved 295 horsepower from 4.6 liters, delivering superior power density that European manufacturers had long claimed as their exclusive domain. Sporting a 32-valve, dual overhead camshaft design and all-aluminum construction, the Northstar was light years ahead of the 8-cylinder options found in previous Cadillacs. The technological sophistication was genuine and comprehensive, incorporating advanced features that had previously been reserved for exotic sports cars or extremely expensive European luxury vehicles. The dual overhead cam valve train represented the most significant departure from GM tradition. Each cylinder head featured twin camshafts, precisely controlling 4 valves per cylinder, 2 intake valves for improved breathing at high revolutions per minute, 2 exhaust valves for enhanced scavenging. This configuration allowed the Northstar to maintain strong power output across its entire operating range, from idle to its 6,500 revolutions per minute redline. The Northstar V8 has a die-cast aluminum 90-degree block with a bottom-end girdle that splits along the midline of the crankshaft bearings. This takes the place of the main bearing caps. This sophisticated construction technique eliminated the traditional main bearing caps, creating a more rigid and precise crankshaft support system that reduced vibration while increasing durability under high-performance operation. The all-aluminum construction delivered benefits beyond simple weight reduction. The aluminum block and heads provided superior thermal conductivity compared to cast iron, allowing more efficient heat dissipation and more precise temperature control. This thermal efficiency enabled higher compression ratios and more aggressive timing advance without the detonation problems that plagued high-performance iron engines. An all-aluminum engine block and cylinder head, dual overhead camshafts, and sequential fuel injection completed the technological showcase. The variable valve timing system adjusted cam timing based on engine speed and load, optimizing power delivery and fuel economy across all operating conditions. Sequential fuel injection provided precise fuel metering to each cylinder, improving both performance and emissions compliance. The manufacturing precision required for Northstar production exceeded anything GM had previously attempted. Component tolerances were specified to levels typically found in aerospace applications. The aluminum casting process utilized advanced metallurgy techniques to achieve consistent material properties throughout each engine block. Assembly procedures incorporated computer-controlled torque specifications and precision measurement systems. It was capable of developing up to 300 horsepower and 295 pound-feet of torque, making it one of the era's most powerful FWD engines from a U.S. automaker. The power output placed the Northstar among the most potent naturally aspirated engines available in any luxury vehicle, regardless of country of origin. The first Northstar engine, RPO code L37, was launched in the 1993 Cadillac Allanté Roadster and the Cadillac Eldorado. It displaced 4.6 liters and delivered 295 horsepower and 290 pound-feet of torque. The debut applications were carefully chosen to maximize the engine's impact on Cadillac's reputation and demonstrate its capabilities in the most demanding luxury vehicle segments. The advanced ignition system represented another technological breakthrough for American manufacturers. Individual coil-on-plug ignition for each cylinder eliminated the distributor entirely, providing more precise timing control while reducing maintenance requirements. The sophisticated engine management system monitored dozens of sensors to optimize ignition timing, fuel delivery, and emission control under all operating conditions. Perhaps most impressively, the Northstar incorporated what GM marketed as limp-home capability. Advanced thermal management systems and protective engine controls theoretically allowed the engine to continue operating even after complete coolant loss, enabling drivers to reach service facilities rather than being stranded by cooling system failures. The oil circulation system featured dual pumps and sophisticated flow control to ensure adequate lubrication under all conditions. The high-pressure oil system maintained proper bearing lubrication even during sustained high revolutions per minute operation, while the advanced filtration system protected critical components from contamination. Fuel economy projections showed the Northstar achieving EPA estimates that matched smaller displacement engines while producing significantly more power. This combination of performance and efficiency had never been achieved by an American V8, proving that sophisticated engineering could deliver benefits across all performance metrics. The noise, vibration, and harshness characteristics that had traditionally plagued American V8 seconds were virtually eliminated through careful engineering. The Northstar's perfect 90-degree V configuration required no balance shafts, while advanced engine mounting systems isolated any remaining vibration from the passenger compartment. On paper, the Northstar represented everything Cadillac needed to restore its technological reputation and compete effectively with the world's most sophisticated luxury engines. The specifications exceeded European competitors, while the advanced features demonstrated that American manufacturers could innovate when properly motivated and funded. The revolution was complete in every measurable way. After decades of technological inferiority, American engineers had created an engine that could legitimately claim superiority over any global competitor. The Northstar promised to prove that Detroit could not only match but exceed the engineering sophistication of Germany and Japan. The only question remaining was whether the revolutionary design would prove as reliable in customer hands as it was impressive on paper. The launch year 1993 marked Cadillac's most confident product debut in decades. The Northstar engine made its production debut in the Allanté Roadster and Eldorado Coupe, representing Cadillac's technological flagship in their most prestigious vehicle segments. For the first time since the 1970s, Cadillac engineers believed they had created something genuinely superior to European competition. After a delayed and limited rollout of the new Northstar engine in two power configurations for the 1993 and 1994 model year, Cadillac enjoyed a wave of positive press. With an entirely new product portfolio in place by 1994, the Northstar-filled Cadillac lineup was ready to roll through the remainder of the 90s. Car and Driver's assessment was particularly significant for Cadillac's credibility. Cadillac's Northstar V8 is thoroughly impressive in the Allanté and Seville, and GM's engineering capability is a match for any in the world. So Cadillac really might have cooked up a full-size luxury cruiser with wings at its ankles. This represented a complete reversal from the skepticism that had characterized automotive journalism's view of Cadillac throughout the 1980s. The 1994 model year expansion brought the Northstar to the Seville STS sedan, creating Cadillac's most credible challenger to BMW's 5 Series and Mercedes E-Class. The STS demonstrated that American luxury manufacturers could create sophisticated sports sedans that matched European performance while maintaining traditional comfort expectations. Early customer reaction was overwhelmingly positive. Owners who had been considering BMW or Mercedes purchases found themselves genuinely impressed by the Northstar's combination of smooth power delivery and sophisticated refinement. The engine delivered on its promises of European-level sophistication with American reliability expectations. Cadillac dealers experienced something they hadn't felt in years: genuine pride in their product's technical capabilities. Sales representatives could honestly claim that their vehicles featured more advanced technology than comparable European models. The conquest sales that had been bleeding to import brands began reversing as affluent buyers discovered that American luxury had regained technological credibility. The market response validated GM's massive investment in Northstar development. Cadillac sales increased significantly in the early 1990s, with much of the growth attributed to the Northstar's reputation for advanced engineering. The engine had achieved its primary objective of attracting younger, more affluent buyers who had previously dismissed American luxury vehicles. Industry analysts proclaimed the Northstar a watershed moment for American automotive technology. After decades of playing technological catch-up with European and Japanese competitors, Detroit had created an engine that could legitimately claim leadership in the luxury segment. The implications extended beyond Cadillac to suggest that American manufacturers could compete effectively when properly motivated and funded. The technical sophistication was undeniable and impressive in real-world operation. The Northstar delivered smooth, linear power that rivaled the best European V8 seconds while producing more horsepower than most naturally aspirated competitors. The refinement characteristics that had previously been European exclusives were now available in American luxury vehicles. Consumer Reports, traditionally skeptical of American luxury claims, acknowledged the Northstar's impressive specifications and initial performance. While maintaining their characteristic caution about long-term reliability, the publication recognized that GM had created something genuinely advanced and competitive. The financial markets reflected investor confidence in Cadillac's technological turnaround. GM's luxury division was attracting the younger, more affluent customers that represented the future of luxury sales. Market research showed conquest sales from European brands increasing dramatically, proving that the Northstar could win over precisely the sophisticated buyers Cadillac needed. European automotive publications, traditionally dismissive of American engineering, grudgingly acknowledged the Northstar's advanced specifications. German technical magazines noted that GM had successfully incorporated design elements that had previously been European exclusives, while Japanese industry analysts recognized the engine as legitimate competition for their own advanced powertrains. The honeymoon period lasted approximately 18 months, during which everything proceeded exactly according to GM's optimistic projections. The Northstar delivered on its promises of smooth power, impressive performance, and sophisticated refinement. Customers were satisfied, critics were convinced, and competitors were genuinely concerned about American technological capabilities. Cadillac's internal market research showed exactly the results executives had hoped to achieve. The Northstar was attracting conquest sales from European brands, lowering the average age of Cadillac customers, and restoring the brand's reputation for technological leadership. The billion-dollar investment appeared to be paying dividends in customer satisfaction and market credibility. For approximately 500 days, General Motors believed they had solved Cadillac's competitive problems through superior engineering and advanced technology. Then the service calls started arriving at Cadillac dealerships across the country. The first signs appeared in service bays across America during the winter of 1994. Cadillac technicians accustomed to working on simple pushrod V8 seconds suddenly faced engines that resembled European exotics more than traditional American power plants. The Northstar's dual overhead cam system demanded precision tools they didn't own, diagnostic procedures they hadn't learned, and repair techniques completely foreign to mechanics trained on decades of conventional GM engines. At Morrison Cadillac in Minneapolis, master technician Frank Rodriguez received his first Northstar service manual in December 1994. The document weighed more than most complete engine manuals he'd encountered in 20 years of GM service. 4 valves per cylinder instead of 2. Twin camshafts per bank instead of a single cam in the block. Aluminum construction requiring torque specifications unlike anything he'd memorized for cast iron engines. The complexity overwhelmed dealerships nationwide. The complexity of Northstar engines meant they quickly became notorious for head gasket failures, but the problems extended far beyond gasket issues. Simple maintenance procedures that took 30 minutes on a conventional V8 required 2 hours on the Northstar. Oil changes demanded special procedures to prevent air pockets in the sophisticated dual oil pump system. Coolant flushes required following precise bleeding sequences that many technicians struggled to execute correctly. Cadillac's training program proved woefully inadequate for the technical revolution they'd unleashed. Weekend seminars and videotapes couldn't transform pushrod specialists into DOHC experts overnight. Dealers complained that GM expected them to service engines as complex as those found in Mercedes-Benz vehicles without providing Mercedes-level training or support. The diagnostic equipment presented another hurdle. While conventional GM engines could be diagnosed with basic scanners and mechanical gauges, the Northstar's sophisticated engine management system required computer interfaces that many dealerships hadn't purchased. Error codes that should have pinpointed problems instead led technicians down diagnostic dead ends as they struggled to interpret data from systems they barely understood. Customer complaints began surfacing with increasing frequency throughout 1995. The problem seemed minor at first, but revealed underlying issues that would eventually destroy the engine's reputation. Owners reported rough idle conditions that conventional tune-up procedures couldn't resolve. Mysterious coolant loss that defied traditional leak detection methods. Oil consumption levels that seemed excessive for a brand new engine, but fell within GM's broad, acceptable parameters. The repair costs shocked customers accustomed to straightforward American V8 maintenance expenses. A timing chain replacement that might cost $800 on a conventional engine approached $2,000 on the Northstar due to the labor intensity required to access dual overhead cam systems. Valve adjustments, virtually unknown on hydraulic lifter-equipped pushrod engines, became regular maintenance items costing hundreds of dollars every 30,000 miles. Independent repair shops refused Northstar work entirely or charged substantial premiums for services they considered high risk. The sophisticated engine management systems and aluminum construction techniques lay outside their expertise and comfort zones. Customers discovered their expensive luxury vehicles had become service orphans, dependent on dealer networks that charged premium prices while struggling to understand the technology they were repairing. Behind the scenes, GM engineers were beginning to document problems that would eventually prove catastrophic. Internal service bulletins from late 1995 referenced cooling system inefficiencies in high-temperature conditions. Technical notes mentioned concerns about thread engagement in aluminum block applications under thermal stress. Quality control reports identified variations in head bolt torque specifications that could affect long-term gasket integrity. The head bolt issue represented the most serious emerging concern. The 4.6 liters V8 engine found in models from 1995 to 2005 were notorious for failure due to a design flaw involving the use of torque to yield bolts in the head gasket. These specialized fasteners were designed to stretch during installation, theoretically providing more consistent clamping force than conventional bolts. However, the Northstar's aluminum block couldn't withstand the stress patterns created by this stretching process. Engineering reports from 1995 noted instances where head bolts had pulled threads from aluminum block material during routine service procedures. The fine steel threads that secured the Northstar's heads to its sophisticated aluminum block were gradually working loose under thermal cycling stress. Temperature management became another emerging concern as real-world driving conditions differed from laboratory testing. The Northstar's advanced aluminum construction provided superior heat dissipation compared to cast iron engines, but the sophisticated cooling system proved sensitive to maintenance variations. Coolant mixture ratios that would be acceptable in conventional engines caused corrosion issues in aluminum applications. Air pockets trapped during improper bleeding procedures created hotspots that stressed the head gasket system beyond design limits. Service managers across the country began recognizing patterns in Northstar complaints that suggested systematic rather than isolated issues. Oil consumption issues seemed more prevalent in certain production periods, suggesting manufacturing variations rather than customer abuse. The sophisticated diagnostic systems that GM had touted as advantages were becoming customer frustration sources. Error codes that should have simplified troubleshooting instead created confusion as technicians struggled to interpret complex engine management data. The Northstar's ability to compensate for developing problems through adaptive strategies masked symptoms until failures became catastrophic rather than providing early warning opportunities. By late 1995, the honeymoon period was definitively ending. The automotive press began noting that Northstar-equipped Cadillacs required more frequent dealer visits than comparable European luxury vehicles. Consumer satisfaction surveys showed declining scores for Cadillac service experiences. Most ominously, early lease returns were increasing as customers discovered that European engineering complexity had been paired with American service network limitations. The revolution that was supposed to restore Cadillac's technological credibility was beginning to reveal fundamental flaws that would transform triumph into disaster. The most sophisticated engine ever produced by an American manufacturer was becoming a customer relations nightmare that would ultimately damage the brand more than any previous engineering failure. The call came into Johnson Cadillac in Houston on a sweltering July morning in 1996. Beverly Martinez was stranded on Interstate 45, white smoke billowing from beneath the hood of her 18-month-old Seville STS. The temperature gauge had spiked into the red zone before she could reach an exit. Now her $45,000 luxury sedan sat cooling on the shoulder while tow trucks navigated rush-hour traffic to collect another casualty of GM's technological moonshot. Martinez's experience would be repeated thousands of times across America as the Northstar's fundamental flaw revealed itself with devastating consistency. The revolutionary engine that was supposed to restore Cadillac's reputation became the source of the most expensive and widespread reliability disaster in the brand's history. The root cause lay buried within GM's most sophisticated engineering achievement. The head bolts were threaded too finely and lost their integrity with heat cycling and stress. The fine steel threads of the torque to yield head bolts on early engines would strip right out of the aluminum block. What started as an elegant engineering solution became a catastrophic design flaw that would haunt Cadillac for decades. Torque-to-yield bolts represented advanced fastener technology borrowed from aerospace applications. Unlike conventional bolts that relied on simple torque specifications, these specialized fasteners were designed to stretch during installation, theoretically providing more consistent clamping force across the head gasket surface. European manufacturers had successfully implemented similar systems in their aluminum engines, proving the concept's viability in sophisticated powertrains. GM's implementation, however, contained a fatal miscalculation. The Northstar's aluminum block featured relatively fine thread pitch to accommodate the bolt pattern required for the dual overhead cam architecture. Under the immense clamping loads generated by torque to yield installation procedures, these delicate aluminum threads couldn't withstand the stress patterns created by the stretching fasteners. The failure mechanism was insidious and progressive. The aluminum block cylinder head bolt hole threads either corrode or fail due to casting flaws, the head bolt loosens, the gasket fails. Thermal cycling from normal engine operation gradually worked the stretch bolts against the aluminum threads. Each heat and cool cycle created microscopic movements that slowly degraded the thread engagement between steel fasteners and aluminum block material. The symptoms began subtly, masquerading as minor maintenance issues that could be dismissed or misdiagnosed. Owners noticed slight coolant loss that seemed consistent with normal evaporation. Occasional rough idle conditions appeared intermittently, cleared by highway driving, and disappeared before technicians could document the problem. The Northstar's sophisticated engine management system compensated for developing gasket leaks by adjusting fuel delivery and ignition timing, masking symptoms until the situation became catastrophic. A blown head gasket in a Northstar engine typically causes coolant mixing with oil, overheating, and white exhaust smoke. Symptoms include coolant leaks, overheating, and white exhaust smoke. When the head gasket finally failed completely, the results were unmistakable and devastating. Sweet-smelling coolant would pour from the exhaust system as combustion gases forced their way into cooling passages. Engine oil turned into chocolate milk as coolant contaminated the lubrication system. The distinctive white smoke that emerged from Northstar-equipped Cadillacs became a roadside signature that other motorists learned to recognize and avoid. The repair nightmare began when customers discovered that head gasket replacement on the Northstar required complete engine removal. The sophisticated dual overhead cam design and transverse mounting configuration made in-vehicle service virtually impossible for major repairs. Solutions require removing the engine, installing inserts, and reinstalling engine, typically about $3,000. What should have been a routine gasket replacement became an engine rebuild project that cost more than many customers had paid for their entire vehicles. At Suburban Cadillac outside Detroit, service manager Tom Richardson watched his customer satisfaction ratings plummet as Northstar failures accelerated throughout 1997. The same customers who had praised their vehicle's performance and sophistication now faced repair estimates that exceeded $5,000 for what appeared to be routine maintenance issues. Insurance companies refused to cover the repairs, classifying them as maintenance rather than accident damage. The financial impact on customers proved devastating. Richardson documented cases where owners abandoned their vehicles rather than invest repair costs that exceeded the car's depreciated value. He had the repair bill of $2,500 become a common refrain in service departments, representing the minimum cost for proper head gasket repair with thread insert installation. Many customers opted for temporary solutions that inevitably failed, leading to even more expensive repairs, as damaged engines required complete rebuilding. Dealers found themselves caught between angry customers and corporate policies that provided little recourse for obvious design defects. Warranty coverage typically expired before head gasket failures manifested, leaving customers responsible for repairs that resulted from fundamental engineering flaws rather than maintenance negligence. Service departments experienced the frustration of repeatedly repairing the same systematic problem, while headquarters denied any widespread issues existed. The technical solution to the thread failure problem involved installing threaded inserts into the damaged aluminum block holes. If there is any section of the aluminum block thread on the bolt, that hole will need a Timesert repair. Typically, all the cylinder head bolt holes do not need Timeserts. These hardened steel inserts, known as Timeserts or Heli-Coils depending on the manufacturer, provided the thread strength that GM's original design had lacked. However, the insert installation process required precision machining that many repair shops couldn't execute properly. The aluminum block had to be perfectly positioned, while specialized cutting tools created precisely sized holes for the threaded insert. Any deviation from exact specifications would result in insert failure and complete engine replacement. The complexity transformed routine repairs into specialized machining operations that only experienced shops could perform reliably. Independent repair shops faced their own nightmare scenario. The sophisticated diagnostic equipment required to properly diagnose Northstar problems cost thousands of dollars that small shops couldn't justify for repairs they performed infrequently. The aluminum construction and complex timing systems required tools and expertise that most technicians lacked. Many shops simply refused Northstar work entirely, referring customers back to dealers who charged premium prices for repairs they struggled to execute properly. The used car market reflected the growing awareness of Northstar reliability issues. Vehicles that had initially held their value well began depreciating rapidly as informed buyers avoided anything equipped with the problematic engine. Auction reports from late 1997 showed Northstar-equipped Cadillacs selling for significantly less than comparable vehicles with conventional powertrains. Dealers began accepting the engines as trade-in penalties rather than selling points. Northstar engines made before 2002, especially models from 1993 to 1999, are prone to head gasket failures. 1997 was the most troublesome. The 1997 model year emerged as particularly problematic, suggesting that production variations or supplier changes had exacerbated the underlying design flaws. Owners of these vehicles faced almost inevitable head gasket failure, typically occurring between 60,000 and 100,000 miles, regardless of maintenance quality. Consumer advocacy groups began documenting the scope of the Northstar head gasket problem as complaints flooded state attorney general offices and federal regulators. The pattern was too consistent and widespread to dismiss as isolated incidents or customer abuse. Thousands of owners were experiencing identical failures at similar mileage intervals, suggesting systematic design defects rather than random reliability issues. The scandal deepened as GM's internal communications revealed that engineers had identified potential thread engagement problems during development, but had proceeded with production to meet aggressive launch deadlines. Cost reduction pressures had eliminated more robust fastening solutions that might have prevented the catastrophic failures that were destroying customer confidence in the brand. Legal action began emerging as owners organized class action lawsuits, alleging that GM had sold vehicles with known defects while concealing the problems from customers. The suits claimed that the Northstar's sophisticated marketing had hidden fundamental flaws that made the engines unsuitable for normal passenger car service. Depositions revealed internal documents suggesting that GM had prioritized meeting launch schedules over resolving engineering concerns about aluminum thread strength. By 1998, the head gasket scandal had transformed the Northstar from Cadillac's technological showcase into an automotive cautionary tale. The engine that was supposed to demonstrate American engineering superiority had instead become synonymous with expensive failures and customer abandonment. The reputation damage would prove more lasting and destructive than any previous Cadillac reliability issue. The revolution that began with such promise had become a disaster that would haunt the brand for generations. Cadillac's marketing department transformed the Northstar's emergency operating mode into one of automotive history's most misleading sales promises. Advertised as 50 miles at 50 miles per hour with no coolant, the limp-home feature became a cornerstone of Cadillac's technological superiority claims is less than #0. 5# is greater than. Dealer brochures proclaim that Northstar owners would never be stranded by cooling system failures, positioning American engineering as more reliable than European competitors. The reality proved devastatingly different. When cooling systems failed, the sophisticated engine management system would supposedly shut off half the cylinders and rely on oil circulation for heat dissipation. The technique, combined with its all-aluminum construction and large oil capacity, allows the engine to maintain safe temperatures, allowing a Northstar-equipped car to be driven with no coolant for about 100 miles without damage, according to GM specifications. The emergency mode often failed to engage properly or proved insufficient to prevent catastrophic engine damage. Owners discovered their Northstar engines seizing within miles of coolant loss, despite following GM's published procedures. The aluminum construction that supposedly enabled limp-home operation actually made engines more vulnerable to thermal shock when the system failed to function as advertised. Cadillac recommends running in limp mode for up to 50 miles, although there is some skepticism about real-world effectiveness. Independent testing revealed that stop-and-go traffic, high ambient temperatures, or aggressive driving conditions could overwhelm the emergency cooling system almost immediately. The limp-home promise became a punchline in automotive circles and a central claim in class action lawsuits. Owners felt deceived by marketing that suggested their vehicles possessed magical reliability properties that didn't exist in practice. Although many Northstar engines include a limp-home mode to keep the engine running even if the coolant tank ran dry, we strongly recommend you apply K-Seal to fix it as soon as possible and prevent further damage. The feature that was supposed to demonstrate Northstar superiority instead became evidence of GM's disconnect between engineering promises and customer reality, further eroding trust in Cadillac's technological claims. The Northstar's oil consumption became legendary among automotive technicians and owners alike. The actual tolerance limit is 1 quart per 1,000 miles according to GM specifications, a consumption rate that shocked customers accustomed to conventional V8 seconds that might burn a quart every 5,000 miles or more. Cadillac's explanation proved as frustrating as the problem itself. This is due to the aggressive and deep hatch pattern on the cylinder walls to promote good high-speed oiling. Downside is increased consumption over a normal design. GM claimed the cross-hatch cylinder bore finish necessary for proper lubrication under high revolutions per minute operation inevitably resulted in increased oil consumption. Design intent for oil consumption would put the engine at about 4,000 miles per quart consumption, but due to the variables in production parameters, there are engines that will use 1 quart per 1,000 to 1,500 miles, perfectly normal and acceptable. The wide variation between individual engines meant owners never knew whether they'd purchased a good or bad oil burner until thousands of miles after purchase. Customer experiences ranged from acceptable to catastrophic. The oil burning created secondary problems that GM hadn't adequately addressed. Carbon buildup on intake valves became endemic as burned oil residue accumulated over time. The sophisticated dual overhead cam system proved sensitive to carbon deposits that disrupted valve timing and airflow patterns. Owners reported rough idle conditions, reduced power output, and failed emissions tests as carbon contamination worsened. Independent repair shops identified patterns linking oil consumption to carbon-related drivability problems. Engines burning oil excessively developed rough idle conditions around 50,000 miles, regardless of maintenance quality. The Northstar's direct injection system amplified carbon issues as oil residue combined with fuel deposits on critical engine surfaces. Online forums filled with frustrated owners seeking solutions for oil consumption that GM dismissed as normal. The 7-quart oil capacity that had been marketed as a performance advantage became an expensive maintenance burden as owners faced frequent oil additions between service intervals. What began as an engineering sophistication became a customer relations disaster that further damaged Cadillac's reliability reputation. The Northstar transformed Cadillac ownership from luxury experience into financial nightmare. Vehicles that had initially held their value well began depreciating at rates that stunned dealers and devastated owner equity. A 1997 Seville STS that sold for $45,000 net became worth less than $8,000 by 2003, primarily due to potential engine repair costs that exceeded the vehicle's market value. Used car buyers discovered that Northstar-equipped Cadillacs carried hidden time bombs. Seemingly well-maintained vehicles with pristine interiors and gleaming paint could require $5,000 engine repairs within months of purchase. Savvy buyers learned to avoid any Cadillac equipped with the infamous engine, leaving a shrinking pool of uninformed customers to absorb the depreciation losses. Warranty coverage proved inadequate for the systematic problems plaguing Northstar engines. Head gasket failures typically manifested after warranty expiration, leaving customers responsible for repairs that resulted from fundamental design flaws rather than maintenance negligence. Dealers sometimes refused warranty claims, arguing that customer abuse or inadequate maintenance had caused failures that independent analysis proved were inherent design problems. Independent repair shops faced their own dilemma with Northstar service. Many shops refused the work entirely, lacking the specialized tools and diagnostic equipment required for proper repairs. Those willing to attempt Northstar service charged substantial premiums for work they considered high risk. The complexity of aluminum engine repair meant that mistakes could result in complete engine replacement, liability that small shops couldn't afford. The repair ecosystem failed customers at every level. Dealers charged premium prices for work they struggled to execute properly, while independent shops either refused service or charged enough to cover potential liability. Customers found themselves trapped between expensive dealer service and limited alternatives for complex repairs. Insurance companies refused to cover head gasket repairs, classifying them as maintenance rather than accident damage, despite the obvious design defect origins. Extended warranty companies excluded Northstar coverage or charged premiums that reflected the engine's reputation for expensive failures. The financial impact extended beyond individual owners to affect Cadillac's entire market position. Lease residual values plummeted as financial companies recognized the engine's impact on long-term value. Fleet buyers avoided Northstar-equipped vehicles entirely, eliminating important sales volumes that had traditionally supported luxury manufacturing economics. Cadillac had created the most expensive maintenance proposition in luxury automotive history. General Motors quietly implemented engineering changes throughout the Northstar's production run, addressing the most serious reliability issues while avoiding publicity that might acknowledge systematic design flaws. The 1996 model year brought revised head gasket materials and modified torque specifications aimed at reducing thread failure rates in aluminum blocks. The most significant improvements came with the 2000 model year redesign. Engineers developed stronger thread engagement specifications and modified the head bolt design to reduce stress concentrations in aluminum block material. The torque-to-yield fastener system received refinements that addressed the thread-pulling problems that had destroyed so many early engines. Production changes included improved aluminum casting techniques that provided more consistent thread strength throughout the engine block. Quality control procedures were enhanced to catch thread engagement problems during assembly rather than after customer delivery. The oil consumption issues received attention through revised piston ring specifications and modified cylinder bore finishing techniques. The 2004 through 2011 model years represented the Northstar's mature phase, with reliability approaching acceptable levels for luxury vehicle applications. Head gasket failures became less common, while oil consumption settled into ranges that most customers found tolerable. The limp-home mode received software updates that improved its real-world effectiveness during cooling system emergencies. However, the improvements came too late to restore customer confidence in Cadillac's engineering credibility. Potential buyers had learned to avoid Northstar-equipped vehicles entirely, regardless of model year or documented improvements. The used car market continued reflecting the engine's early reputation, with late-model vehicles suffering depreciation penalties despite their superior reliability. Automotive journalists rarely mentioned the Northstar improvements, focusing instead on Cadillac's struggles to compete with import luxury brands that had gained market share during the engine's problematic years. The technical press acknowledged the engineering refinements but questioned whether American luxury manufacturers possessed the quality control capabilities necessary for sustained competitiveness. Internal GM communications revealed frustration with the market's failure to recognize Northstar improvements. Engineers had successfully addressed the most serious design flaws, but marketing departments couldn't overcome the reputation damage created by early reliability disasters. The brand damage proved more lasting and destructive than any engineering problem. By 2005, even improved Northstar engines couldn't compete effectively with simpler, more reliable powertrains that offered comparable performance without complexity-related maintenance burdens. GM's technological success had become a cautionary tale about innovation without adequate durability validation. Class action lawsuits emerged across multiple states as Northstar owners organized to seek compensation for systematic design defects that GM had concealed from customers. Legal filings alleged that Cadillac had marketed vehicles with known reliability problems while representing the engine as advanced engineering suitable for luxury vehicle applications. The automotive press that had initially praised the Northstar's sophistication began documenting its reliability disasters. Consumer Reports downgraded Cadillac recommendations across model lines equipped with the problematic engine. Motor Trend published investigations into head gasket failure patterns that revealed the scope of GM's engineering miscalculation. Online forums became repositories for Northstar horror stories as owners shared repair experiences and warned potential buyers about the engine's hidden costs. The Caddy Info forum developed extensive technical discussions about Northstar problems, while Edmunds customer reviews consistently cited engine reliability as the primary reason for avoiding Cadillac products. Market research showed Cadillac losing traditional customers to import luxury brands at accelerating rates. BMW and Mercedes-Benz sales surged as affluent buyers discovered that European reliability had improved while American luxury engineering had stagnated. Lexus captured the value-conscious segment with vehicles that offered Cadillac comfort without engine reliability concerns. Depreciation studies revealed that Northstar-equipped Cadillacs lost value faster than any comparable luxury vehicles from competing manufacturers. A 2000 Cadillac Seville worth $18,000 in 2005 would sell for less than half that amount solely due to potential engine repair costs, while comparable BMW and Mercedes vehicles retained significantly more value. The reputation damage extended beyond individual model lines to affect Cadillac's entire brand image. Focus group research showed that younger luxury buyers associated Cadillac with unreliability and high maintenance costs rather than prestige and sophistication. The conquest sales that GM had expected from technological superiority never materialized, as informed buyers avoided the brand entirely. Dealer networks suffered as service departments became overwhelmed with warranty claims and customer complaints about expensive repairs. Many dealers reported losing money on Northstar service work due to the complexity and time required for proper repairs. Customer satisfaction scores plummeted as owners faced repeated reliability problems with their expensive luxury vehicles. The Northstar had achieved the opposite of its intended effect, driving customers away from Cadillac rather than attracting them to American luxury engineering. The engine became automotive shorthand for ambitious engineering, undermined by inadequate execution. The Northstar's demise came without fanfare or corporate acknowledgement of failure. Production ceased in 2011 as Cadillac quietly transitioned to proven powertrains that prioritize reliability over technological sophistication. GM avoided publicity surrounding the engine's retirement, allowing it to fade away rather than drawing attention to nearly 2 decades of engineering problems. Cadillac's new engine strategy represented a complete philosophical reversal from the Northstar era. The brand adopted GM's proven LS Series pushrod V8 engines that had demonstrated reliability in Chevrolet Corvette applications. These conventional designs offered comparable performance while eliminating the complexity that had plagued Northstar ownership. Smaller displacement turbocharged engines became Cadillac's technology showcase, providing efficiency and performance without the maintenance nightmares associated with dual overhead cam aluminum construction. The CTS and ATS model lines launched with powertrains borrowed from successful European applications rather than ambitious in-house developments. The engineering talent that had created the Northstar was reassigned to other projects as GM management concluded that revolutionary engine design had been a strategic mistake. Future Cadillac powertrains would emphasize proven technologies and evolutionary improvements rather than quantum leaps in sophistication. Industry analysts noted the irony that Cadillac's most ambitious engine project had driven customers towards simpler, more reliable designs. The market had rejected complexity in favor of dependability, lessons that German luxury manufacturers had learned decades earlier through their own reliability struggles. Media coverage of the Northstar's end remained minimal, as automotive journalists focused on Cadillac's future products rather than examining past failures. The few retrospective analyses acknowledged the engine's technical achievements, while noting that reliability problems had overshadowed any performance advantages. Used car markets continued reflecting the Northstar's reputation long after production ended. Vehicles equipped with the engine maintained lower residual values than comparable models with conventional powertrains. Informed buyers avoided Northstar-equipped vehicles entirely, leaving them for customers unaware of the engine's problematic history. GM never issued official statements about Northstar reliability problems or acknowledged that design flaws had caused widespread customer dissatisfaction. The engine simply disappeared from Cadillac's lineup as the company pursued different engineering directions. The most technologically advanced American V8 engine became a terrible tale about innovation without adequate validation, quietly ending an era of ambitious but flawed automotive engineering. 25 years after its introduction, the Northstar stands as one of automotive history's most complex cautionary tales. General Motors invested over $1 billion developing what should have been their technological masterpiece, only to create an engine that nearly destroyed the brand it was meant to save. The story reveals how good intentions, ambitious engineering, and corporate pride can combine to produce disasters that exceed any single failure in scope and consequence. The Northstar's technical specifications remain impressive by contemporary standards. Dual overhead cams, 4 valves per cylinder, all aluminum construction, and sophisticated engine management represented genuine advances over conventional American V8 designs. European manufacturers had proven that such technologies could deliver both performance and reliability when properly executed and validated. GM's execution revealed the dangers of rushing revolutionary technology to market without adequate real-world validation. The torque-to-yield headbolt system that worked perfectly in laboratory conditions couldn't withstand the thermal stress patterns created by everyday driving in aluminum block applications. The fine threads that provided precise clamping force gradually worked loose under thermal cycling, creating catastrophic gasket failures that destroyed customer confidence. The oil consumption problems stemmed from similar validation failures. Engineers had specified cylinder wall crosshatch patterns that promoted high revolutions per minute lubrication, but created excessive oil burning under normal driving conditions. What seemed acceptable in performance testing became customer frustration when owners faced weekly oil additions and carbon buildup problems that affected long-term reliability. The limp-home marketing represented everything wrong with GM's relationship with customers during this era. Engineers had created a sophisticated emergency operating mode that functioned under specific laboratory conditions, but marketing departments transformed it into unrealistic promises that couldn't be fulfilled in real-world applications. Customers felt deceived when their expensive luxury vehicles failed to deliver advertised capabilities. The complexity that GM marketed as sophistication became a customer service nightmare when dealer networks lacked the training, tools, and expertise necessary for proper maintenance and repair. European luxury manufacturers had spent decades developing service infrastructures capable of supporting advanced engine technologies, while GM expected American dealers to instantly master techniques that required years of specialized training. The financial impact extended far beyond individual repair costs to affect Cadillac's entire market position. The brand lost credibility with precisely the affluent, educated customers it needed to compete with import luxury manufacturers. BMW, Mercedes-Benz, and Lexus gained market share while Cadillac struggled to overcome reputation damage that persisted long after engineering improvements had addressed the most serious reliability problems. Perhaps most tragically, the Northstar's failure overshadowed genuine engineering achievements that deserved recognition. The aluminum construction techniques, sophisticated engine management systems, and dual overhead cam designs represented legitimate technological advances that would influence engine development for decades. These innovations were lost in the narrative of reliability disasters and customer abandonment. The late production Northstars from 2004 through 2011 had largely solved the head gasket and oil consumption problems that plagued early engines. However, market reputation proved more durable than engineering improvements. Customers had learned to avoid Northstar-equipped vehicles entirely, regardless of documented reliability improvements in newer versions. The Northstar taught the automotive industry that technological sophistication without durability validation creates more problems than it solves. German and Japanese manufacturers studied GM's mistakes while developing their own advanced engines, ensuring that complexity didn't compromise long-term reliability. The lesson influenced engine development strategies worldwide as manufacturers learned to balance innovation with proven durability. For General Motors, the Northstar represented the end of an era when American manufacturers could succeed through marketing promises rather than engineering excellence. The modern Cadillac brand emerged from the Northstar disaster with a renewed focus on proven technologies and evolutionary rather than revolutionary improvements. The shocking truth about the Northstar is not simply that it failed, but that it failed so completely despite representing genuine engineering talent and massive corporate investment. The engine embodied both the best and worst of American automotive ambition, brilliant innovation undermined by inadequate validation and overconfident execution. The Northstar was meant to restore Cadillac's crown, but instead, it became the engine that defined its downfall.